So just to sum this all up, this is straight out of your textbook. I just copied this. The definition and properties of a composite function. The composite function f circle g, pronounced f composition g, or this is my preferred way, f of g, is the function, and it can be written either way. You're usually going to see me write it like this. Okay, but if you see f circle g, that just means f of g of x. And basically, function g is the inside function. So you're going to do that first, okay, using x as its input. And then function f is the outside function, and you evaluate that next. And you saw us doing that in several examples. But so you start with the inside function, you evaluate it first using x as the input. Then you move to the outside function. So you basically take that outside function, you evaluate it next, and g of x is the input, which is the output of g. Okay, so that's basically how you, and then if you had like another function, so if it was f of g of h of x, right, then h of x would be the inside function. You do that first, then you evaluate g of x, then you evaluate f. So you work inside out. And I'll just refer back to example 2. We basically did that in these examples where we were finding f of g of x. So we knew g of 1, right, that inside part right here, was 5. So then we found f of 5, so we went down to f of 5, and we found that. Now sometimes if the domain, if it's not in the domain, then this composition cannot work. So for example, g of 5, okay, g of 5 gave us 7, but there was no f of 7, right? So this composition did not exist. Okay, and that's basically what the rest of this is saying. So the domain of f of g is the set of all values of x. It's got to be in the domain of g. And then that's got to be in the domain of f. So that example, that is shown to you right here with this one that I just went over.